Hello. I would like to explain some of these problems you have with math. Starting with this one about the buffalo. Let's see. Okay. So, share these on the screen. The amount of time it takes to consume a buffalo carcass is inversely proportional. First, we have to decide what we mean by inversely proportional. This is different from direct proportion, you see. Now, direct proportion would be of this nature. You have y equals kx. Not so different. Y equals mx plus b, you see. Now that is direct. Now indirect would be if you have y equals a divided by x. And you see it does not make much difference what you choose to be y and what you choose to be x. As you know, a simple algebraic trick allows you to switch y and x through multiplication and division to make this x equals a over y. So I'm going to make a choice. I'm going to say that these 12 vultures, this 12 is going to be y, and the k is unknown. I do not know what is called the constant of a proportionality. And then I'm going to divide that by the 3 days it takes for the vultures to consume the buffalo. Now, this part was a little bit morbid because it's talking about animals eating another animal, but you eat animals all the time. So, let's see. So, if I multiply both sides by 3, I get k equals 36. 36 is my constant of proportionality. Just in case you did not understand that, I will write it down. This is the constant of proportionality. Okay, so we will apply this constant proportionality to the other information. Now it's asking about what if there are 4 more vultures or more birds eating the buffalo. So that will increase the number 12 to 16. Okay, so where are we getting 16? I will say that comes from 12 vultures plus 4 vultures, giving me 16 equals the constant of proportionality, this k. I'm not going to write k this time. No. I am going to write 36 because we all have already solved it over x. Now, as you saw before, as I pointed out here, you can switch these y and x. So you can switch these two guys and you can get x equals 36 over 16. Now 36 over 16 is 2.25. But what's important here is units. Now we're looking for a unit of time. How long does it take the vultures to consume the buffalo? It's not 2.25 hours, it is 2.25 days because the buffalo is pretty big. So we have 2.25 days. And now it is time to compare. So we have the 3 days. 3 days are for the 12 vultures. Takes them a little bit longer than the 16 vultures, which takes the 2.25 days. And we are left with a mere 0.75 days. Now 0.75, you might say, is equal to 3/4, but it is not the answer. No. We must take 0.75 and multiply it by the number of hours in the day, which is 24. So we're taking 3/4, 3/4 of 24, and it gives us 18 hours. Understand? We have 18 hours. Answer choice is C. Let's go on to the next problem. There, have you sent me? Screen. So for this one, we are we're talking about ice cream scoops, and we have a chart, and we're talking about the mean, median, and the mode. Now, let us first deal with mode. Mode means the most frequent so what has the most? Who is interested most in the amount of scoops that they want? So here I see the frequency of 7. 7 is the rather high frequency for 3 scoops. So I would not say most, but many people want to eat ice cream and enjoy 3 scoops. So our mode in this case is 3 scoops. Now the next I would tackle is the median. Now the median is the middle or something. Now let's take a look at the frequency. The frequency tells us how many people wanted ice cream at this particular day. So we have a frequency of 1, 2, 2, 7, 6, and 6. Now we add 1, 2, 2, 7, 6, and 6, and we believe it arrive at 24. So let's recommend 24 people surveyed. 24. And we want to find the middle. So you count back from each direction. So we're counting back 12 from the top and the bottom. Now if you notice they meet, so you count 12 from the top, 1, 2, 2, 7, that is 12. And the bottom 6 and 6, that is 12 also. So we're in between 2 and 3 scoops. So what do we do? This means that many people want about 2 scoops. Many people want about 3 scoops because people are different hungries, you know. So this is about 2.5 or 2.5 scoops. So we could say, so the median is 2.5 scoops. Now the mean is the most hardest part to calculate. So what does mean mean? So mean is we say the average, right? So if you want to know the mean, you want to know what each person did. So one way to say this is you could say that, okay, so frequency one person, one very probably fat guy ordered 8 scoops of ice cream. Now people who maybe have been very hungry also ordered 5 scoops. So we have 2 plus 5 plus 5. As we get along, we also have 2 that ordered 4. But you see, this is not a good idea. It takes too long. So you want to use multiplication. So we want to find out who ordered what kind of ice cream. So one person got 8 scoops. Two people decided they wanted 5 scoops. So this is really 10 scoops. So then we have 4 people who have, no, sorry, 2 people who have 4 scoops. This is 8 scoops again. And then the most common, most people want 3 scoops of ice cream because they want to enjoy themselves. Now, these people amount to 21 ice cream scoops. Now, for 2 ice cream scoops, we have 12. And for the sad individuals who only want the white ice cream, could you imagine wanting only 1 ice cream scoop when you go out for 1 day? But they have 6 of them. Now we're going to add all these scoops up. So this is the total of scoops, not the total of people. So we got 18, 46, 46, 47, 57, 59, 65. I sometimes think that maybe I made a mistake in that thing, so I'm going to add again. So I got 18 is 26, 36, 46, 47, 57, 59. I'll say that's 65 scoops. So what I'm going to do is take these 65 scoops and divide them by how many people we have. So we've already established that there are 24 people surveyed, 24 people, very hungry people eating ice cream. So we have 64 divided by 24. And now I will take my mobile device and calculate what we're eating here. So we got about 2.708 scoops per person. Okay. So we must compare these amounts. So we got the mode, the scoops, we got the median, 2.5 scoops, and the mean is this is 2.7. You cannot have 2.708 scoops, but this is just a the way it divided. So which one is the biggest? So the biggest looks like the mode, but we look at the answer choices. The answer choices are not about the biggest, it's about the smallest, because they're all in less than. They all use this symbol here, the less than symbol. So we start with the smallest. The smallest is the median, the 2.5 scoops. So we look for median. And then the next biggest will be the mean, these 2.708, and followed by the mode, which is 3 scoops. And the one that matches the most is answer choice C, as you can see. Let's move on to the next one. So let us see what we have here. I see we still have explanations, but I'm going to try to avoid that and see what you could find out ourselves. So, okay. A summer beach volleyball league has 750 play. That's a very, very large summer volleyball league. But anyway, they're surveying people, and they don't survey everybody. They only survey 150. So this is common. Whenever you want to find out an opinion about something, you don't ask everybody. Not everybody. No, you only ask a small portion, and then you extrapolate that data. So you find out what percentage of the people felt a certain way, and then you apply that to all the people, all the players. So now they're only asking 150 players how they feel. This says the result of the poll shows that 42 of the poll players would prefer to play in the rain. They would prefer to play in the rain. It is very unusual. Maybe, perhaps they mean they do not mind playing in the rain. Or maybe if it's a hot day, then they like having the cool rain on top of their heads. But it is not for us to judge. We just got to read the problem and see how they feel and see how it relates to everybody, everybody playing the volleyball game. So now we take these 150 players. So we got 42. 42 like playing in the rain, or playing in the rain, over 150. Now we want to see these percentage. Once again, I will take my mobile device because my calculator is, and I will divide. Now, this gives me 0.28. 0.28 represents the percentage, 28%. Now I'm going to extrapolate. Extrapolate means to take a small piece of data based on a small survey and make a conclusion about everybody. So I'm going to take 28%, is 0.28, and I'm going to multiply it by all the players in the league, the 750. I get 10. Now, right away, if you look at 10, there's only one answer choice that makes sense, and that's this one. But that will not always happen. You see. So you have to take other information into account if that doesn't happen. So I will take this part, this plus or minus 4%. Plus or minus 4% would mean that we take the percentage that we found and add and subtract 4% from this 28. So this 28 right here becomes 24. And if we add, it becomes 32. Now, of course, when multiplying, we're talking about percentages. So it's 0.24 and 0.32 of the 750. So we have this and this guy. And let's see what happens. So I got 0.24 times 80. Now the next one, I wonder we will get, we have 32 times 750. 40. Look at that. So D is a good answer for us. Now, we are almost done. We have one more problem to go through. Let us see this one. I believe this looks like straightforward algebra. Algebra can be confusing sometimes, you know. So it's a lot of crap on my desktop. This is my friend. Let's see. So we have if x equal y equals 3 to the x. Why in the mumbo jumbo? Don't read the questions to yourself, just jump into it. So you have 3 to the x, and you're also asked about other things to the x. So if you have exponential equations, the best you can do is to make one equation look like the other. So let's take the end of this y 9 to the x plus 3 to the x plus 1. Now the information given is about 3 to the x, so we have to make everything look like that. So let's start up. What does 9 have to do with 3? They are not the same number, no. But you may know that if you take 3 and raise it to the second power, you get 9. So that's what we want to make use of. So 9 is 3 squared. It gets raised to the x. This one is a little bit more tricky. So the exponent here is talking about addition. How do you deconstruct the addition of something? So the rule here is that, let me show you off to the side. So if you take 5 and reduce it to the 6 and multiply it by 5 raised to the 7, this is in fact 5 raised to the 13th power. So if you have 3 raised to the x and multiply it by 3 raised to any power, say 1, you would add the powers. This is the rule of the exponent. So you have 3 to the x plus 1. So that makes this 3 to the x plus 1 you can deconstruct and make it into 3 to the x times 3 to the 1. Now this guy, not 1, 3 squared, we want 3 to the x. But the rules show us that we could do 3 to the x. And then to the second power, because there is no difference between raising one power to another and raising one power to another. It seems like the same word. So 3 to the second power to the x is the same thing as 3 to the x to the second power. It is multiplication. You can switch. This is the commutative problem. So now we have this and 3 to the x, and I shall change this one from a 3 to the first to a 3. Now, check this out. The original problem said 3 to the x is equal to y. And all our answer choices have y. So we want to reintroduce a y into our argument. So we have 3 to the x is y. So this is y squared plus a y times a 3. It still does not look like anything there, so, but maybe we have to manipulate a little bit. So the first thing I look at is eliminating things. Y cubed makes no sense, right? We have a 3y. There's no squared. We need to square y as well. And then these other two are looking quite tasty, but we want to eliminate. So let's look at this. So we have a y and we have a y. So we can maybe factor one of these y's out. So y, and we're left with one y. And we are left with 1, 3. Y, 5 plus 3 was that is our answer. That is it. Goodbye for now. I do not know where the button is for goodbye. I still do not know where the button is for this is a stop recording.